Lecture D07, Principles of Windows and Doors. So all the components which we need to open and close for whatever exchange of inside and outside, may be people, may be goods, may be air in our buildings. This lecture deals with the impact of exterior windows and doors, the doors and window types, assembly position, profiles, and how they're in general manufactured, the 5 profile types we know, and types of fixation in this setup. The interesting thing is when we design a facade, we follow this main picture of influences, radiation, rain, driving rain, temperature differences, wind, noise, ventilation. Movements and humidity from the inside, dead load, own weight as system. And then we create this facade as the one system. But then we have this entire facade and we want it to be opened. So we want an exchange of air from the inside and outside. We want to be able to move people and goods from inside and outside. So we actually have a system, and that system needs to be penetrated to have an opportunity to have an in and outlet within this system. And that means that we need to add a next system to this setup, and these two systems are both to be designed clear, and then the interface between these two systems, that's also an aspect to be, say, taken care of deeply. The window, doors, and types, which we know, the typical window which opens sideways, the side hung, or which tilts, top hung, tilts as a system, or which tilt and turn, the very, say, European window, to allow that it normally opens so that you have access, but you also can tilt it to have ventilation access, vertical pivot, horizontal pivot, so entirely tilting thing, and then the sliding window, horizontal or vertical, as a system. And in the same layout, this can be seen by doors, exactly the same kind of layout, just dimension is larger, and by dimension larger, we also end up with, say, higher dimensions in all the hinges and the details to be taken care of in this system. The typical profiles which we face in this setup, wooden profiles, as a set where we see an low profile and a higher profile. The top profile, the frame itself, that's the one which opens, and it needs to get all this sealant done within the profile. So all the functionality which we expect from a facade, being airtight at the inside, being raintight at the outside, and having this function zoom which insulates it in between, that all has to happen within this profile, but also when it is opened with all the, say, sealant which tighten this window, that has to happen in the same setup. Then second one, an aluminium profile. Here we see, or a combination of wood aluminium profile, so wood at the inner side and then aluminium profile at the outside, which may last longer being exposed to the environment, up to the pure aluminium profile. Here we see the pure aluminium profile. We will talk about the materials and how to make these windows later in other lectures deeper, but it's nicely to see these are extruded profiles with a thermal break profile in between. Aluminium is transporting energy very well. We need to break this energy transport within this area, and that's exactly where the glass itself is positioned in this system. Coming to the next setup, this is the steel profile. It actually looks quite similar to the aluminium profile. The main difference is the way how this steel is made, cold bended is the word here. Again, this is a different lecture to talk about, but they setup work in the same way with this thermal break in between. And then we see the PVC plastic profiles, extruded units, one huge piece. No thermal break necessary because the material itself doesn't transport that simple energy. And we see a reinforcement of steel bars being placed in here depending to the dimension. Again, this is something which we see in the different set of lectures. The way timber structures or wooden profiles are done, main structure being milled, then assembled, laminated at the edges as a system. The aluminium system, how they are mainly done, is 2 of these aluminium units, which are then connected with an L-shaped corner cleat. So this corner cleat is brought in position, then fixed by screws, and keeps the edge stable versus the PVC setup. This is the welding device, and we see two PVC profiles. The one comes from here, the other one comes from here. There's a heating iron in between. It actually heats these two pieces, then the iron is taken out, and then they're pushed together and welded together as two profiles being welded fixed to each other. These are, say, the main three principles how we connect these materials we use for making buildings, windows out of it. How is this brought into position to the main structure? We either bring this central to the main structure, depending on what type of main structure we have. This sample is sheet metal with an insulation material in here. So that's the entire thickness of the structure. And the window is brought exactly in that middle line due to, say, the insulation values being hopefully similar here than here. So it's brought to the same position versus the version in front of the main structure. Why do we do that in front of the main structure? When we go to the detail, we'll see this is main structure and this is insulation. Again, the window is brought in the position where the insulation main line is appearing. So insulation main line happens here. Window has to stay in this position, so it needs to be somehow cantilevered from the main structure. We see the brackets in a minute in some slides. Or it is brought into a curtain wall system. So we see a typical curtain wall system and stick system here, and then the window is brought in position, clamped in the same setup as we normally use these clamps for keeping glass in position as a system. How do we assemble it to the main structure? There are some, say, principal ways of doing. The simplest one is bolting through the frame. So we see the window frame here. It's just bolted in here. Now, yeah, you need to be able to have the main structure there. You need to be able to bolt through the frame. This does not work with aluminum or PVC. It does work with timber. For example, joint bars, so some additional bars being added to this frame system, allowing that this fixation happens here while the insulation in this area. So we would be able to, say, have an offset of the set gliding angles, allowing that there's movement of the main structure versus the window. Larger windows may have this as an aspect of difficulty, or structural metal plates, brackets, which cantilever from the main structure, the window, to the outside, to allow to have some additional insulation, for example, in that area. It could be done also when the window is larger with real mounting brackets, so not just a plate of steel, but a real bracket, which then could take higher loads as a system, or adjustable fixing systems which are delivered by the manufacturer, which allow to get all the tolerances in all directions, being part of the entire window system as a setup, which may perform better in flexibility, but obviously also may be more cost-wise. And by this, we stop this lecture. Again, some literature, and here it ends.